What is bolt preload in a gearbox? This is a very common CAE interview question, especially for automotive companies. Let's understand it using a simple Abaqus model. For a gearbox bolt preload analysis in Abaqus, we have to prepare the assembly by importing the gearbox housing and a bolt. First, we need a CAD file of a gearbox assembly. I have downloaded a CAD file from GrabCAD. The next steps are geometry cleanup and meshing. I use the ANSA preprocessor for it. For the bolt, we will be using hexa mesh, and for the housing, we will be using tetra mesh. From this CAD, we have meshed only a single bolt and a gearbox. Then we define the material properties. For bolt, we will be using steel material with Young's modulus 210 GPa and Poisson's ratio 0.3. And for housing, we are using aluminum alloy with Young's modulus 70 GPa and Poisson's ratio 0.33. Now we will save as the file with only interested elements. Now we have the model with the bolt and a housing. To apply the bolt preload, we need to create a pretension section in the bolt. For that, we will use the pretension wizard. We will select the elements and nodes for defining the vector for the pretension section. Press next and finish the process. By default, it creates a step, boundary and a load. We will define the step, boundary and load separately in the master file. A master file is nothing but a text file in which only commands are written and has your geometry file as an include. So delete this step, boundary and load from the database. We also have to change the pretension vector's direction. For that, go to the pretension section in the database, enable filters x1, x2 and x3, modify these numerical values and keep them blank. If you go to the sets, you can see that a set is auto-created while using this pretension wizard. It represents the pretension section. For applying the preload in master file, we will create a node set. If you make the pretension section visible, you will see that there is a node near the pretension. We will create a set of this node named as preload node and call it in the master file. Now that we have made the provision for applying pretension, we have to also make sure that the preload passes to the housing. But how it is done? The answer is through the contacts. We have to create the contact interactions between the bolt and housing surfaces using surface to surface contact with an appropriate friction coefficient. We will define the contacts in the master file. In this file, we will define the slave and master sets, which we will call while defining the contacts. As the bolt is a smaller component, we will define its element faces into slave sets and the housing into master sets. First, we will create the sets for the bolt head contacts. Then we will create contact sets for the threads. We are also creating a tie contact so that there is no singularity in the model. Once we finish defining these sets, we will create constraints for defining the boundary conditions. We will create kinematic couplings at the other bolt hole locations. To constrain these couplings in the master file, we will create a set called fix containing all the master nodes. The next step is to create the master file. I have created a master file. Here you can see that I have used the star preprint command. These lines are optional. I have just used them so that there is no warning in the dat file. To call our geometry file, I used star include input command. Before defining the contacts, we have to define the surface interactions. I have defined it using star surface interaction. I have given a friction of 10% under the star friction command. We then define the contacts and tie constraints using star contact pair and star tie. In the next line, I have used a star step. Here we are using star static as it is a static linear simulation. In Abaqus, load and boundary conditions are defined under the step. So star boundary and star C load are used to define the boundary conditions and bolt preload respectively. Now we will call the output variables using star output. I have called displacement in star node output, contact pressure in star contact output, and stress in star element output. Energies are called using star energy output, and finally we end the step using star end step. Now the only thing we have to do is to import our model in Abaqus CAE and submit the job. Once the job is completed, we will open the model in Meta Post-Processor and load the contact pressure results. We will log the end step and scale the deformation to 2 for better visualization of the results. Now if we play the animation, we can see that how the bolt preload is getting applied to the housing from the bolt. So in this video, we learned how to apply the bolt preload using Abaqus CAE. Thanks for watching this video. If you found it interesting, share with your friends and do consider subscribing us.